welcome to TechnoStack YouTube channel. Today I came up with new topic of a Snowflake, which is scaling policy. But before start learning today's topic, let's look at what we have covered in the last video. We have covered the detailed architecture of Snowflake. We have seen high-level virtual warehouse concept. We also seen multi-clustering and its types. At the last, I have demonstrated the configuration of warehouse in which we understand the concept of a size, maximum clusters, minimum cluster. Today we are going to discuss the scaling policy, and we have also seen the auto suspension option while configuring the warehouses. So if you have not seen my last video, please request you to watch my last video to understand these topics in detail. So let's begin with our today's topic, that is scaling policy. First, understand what is scaling policy. We know Snowflake provides multi-clustering to achieve parallelism while executing the queries. So the scaling policy is a mechanism which used to automatically start and stop the warehouse as per the requirement of compute resources to execute the query from Snowflake queue. So the selection of the scaling policy while using multi-clustering is very much important as it is directly impacting to the consumption of your credits and the speed of your query execution or the data retrieval. One key note is, as we learned multi-clustering in a last Snowflake video, we also seen multi-clustering provides two modes. One is auto scale and second is a maximized mode. Scaling policy are applies only when we select auto scale multi-clustering, because in maximized mode all warehouses run concurrently, so there is no need to start or shut down the individual warehouse. Let's look at the options provided for the scaling policy into Snowflake. One is standard and second is economic. So the standard option is more favorable to start additional warehouses whenever system detects the new query is laid into the Snowflake. For example, if current warehouse is busy with existing query execution, and if new query arrives into queue, then standard scaling policy will automatically allocate a new warehouse for new query execution. Hence, the standard option consumes more credit and gives the faster performance for the query execution, whereas economy option is more favorable to keep warehouse fully loaded, which means economy option will not start the new warehouse until and unless it confirms the current running warehouse will be busy for next 6 months. If it is not so, the query will remain into queue and wait for warehouse to finish the current execution, which may lead to more time taking complete query execution. But the economy option consumes less credit and provides the slow performance. So let's learn about how Snowflake scaling policy works, how Snowflake achieved to start and stop the warehouses in both options of a scaling policy. Standard mode is a default mode of a scaling policy. When you create the warehouse, the standard scaling policy is applied by default. You can manually change it to economy if you are more concerned about saving the credits than performance of a query execution speed. So let's look at what Snowflake says when to start the warehouse in a standard mode. The Snowflake says the first warehouse starts immediately when either a query is queued or the system detected that there is one more query which is being currently executing in the warehouse. Each successive warehouse waits to start 20 seconds after the prior one has started. For example, if you are using multi-clustering warehouse and which is configured with the 10 max warehouses, so it can take fully 200 plus seconds to start all 10 warehouses. So let me demonstrate this, how the Snowflake starts and shut down the warehouses in a diagrammatical way. Queue, which holds the queries from the Snowflake till any of the warehouse gets allocated to the query which are available into queue. So for example, let's say query 1, query 2. So this is the queue which holds the queries till the warehouse gets allocated to query for the execution. So let's say in our configuration of warehouse, we have been using a multi-clustering where we have set maximum warehouses as a 3. So these are the warehouses which are available into the Snowflake for us. So whenever the query gets arrived into queue, the Snowflake will, without any concerning, Snowflake will allocate the query 1 to the warehouse 1. Because let's say at the very first time, all warehouse 1, warehouse 2 and warehouse 3 is in ideal state. So which means that warehouse 1, warehouse 2 and warehouse 3 is ready for query execution. So where query 1 will consumes the compute resources of warehouse 1 for the query execution. Then meantime, let's say the query 2 arrives into queue. So the Snowflake, in a standard scaling policy, the Snowflake does not look for the query 1 or the warehouse 1. So whenever the query 2 arrives into queue, system will detect that query 2 is queued into queue. So the Snowflake will automatically distribute the query 2 to the warehouse 2 for the query execution. So let's say after query 2, the query 3 has arrived into queue, and then automatically the Snowflake will redistribute the query 3 to warehouse 3 for the execution. So whenever the query get assigned to any of the warehouse will change its states from idle to running, so that Snowflake will understand, okay, this warehouse 1 is running, so that this warehouse has no compute resources free for the execution of another query. So in a standard scaling policy, the query 2, query 3 will get redistributed to another warehouses. So now let's look at how the Snowflake stop the warehouses. So as we have seen how the queries are get distributed to different warehouses, and how the warehouses has started for the query execution. So the Snowflake has a mechanism of to check the warehouse states. So let's say after 2 or 3 consecutive successful checks, which is performed on every 1 minute of an interval. So let's say after every 1 minute, Snowflake checks the state of warehouses which are available into the Snowflake for us. So that checks means with the Snowflake determines whether the load on the least loaded warehouse could be redistributed to other warehouse, which means that let's say the query 1 has started 3 minutes ago, query 2 has started 1 minute ago, and query 3 has started 0.5 minutes ago. Okay, so now when we redistribute the queries to the warehouse 1, warehouse 2, and warehouse 3, for now the query 1 is about to finish its execution. So the more compute resources is available from the warehouse 1, which means that warehouse 1 is the least loaded. So now the Snowflake redistribute the query 2 to the warehouse 1, so that the query 2 will uses the compute resources which are available from the warehouse 1 for the execution. So now the warehouse 2 is become fully available. The warehouse 2 initially it was running, so now it become from running to ideal state, which means that warehouse 2 has stopped his execution, and which is available for next query load for the execution. So this is how the standard scaling policy works to start and stop the warehouses. Each successive warehouses wait for 20 seconds after first warehouse started. Let's say query 1 has arrived at 11 a.m. and query 2 has also arrived at 11 a.m. So both the queries has arrived on the same time. Query 1 has redistributed to warehouse 1, and the query 2 should get redistributed to the warehouse 2. But like warehouse 1 has started 11 a.m. for the execution. So now the Snowflake wait for 20 seconds to start the warehouse 2 and allocate the query 2 to warehouse 2. The same for the query 3. So the keynote is the successive warehouses will wait for 20 seconds after first warehouse start. So let's say if we have configured the maximum warehouses as a 3, so it will take at least 60 seconds to start all the warehouses. So there is a difference between 20 seconds of each warehouse to start. Now we'll go for economy scaling policy to understand. Here, the warehouse start only if the system estimate there is enough query load to keep the warehouse busy for at least 6 minutes, which means as in standard option, Snowflake does not check the query load of each warehouse while allocating the queries. It simply allocates the query to new warehouse for the execution. But in economy mode, Snowflake first check the load of current running warehouse and then decide to start the new warehouse or not. So let's look into diagrammatic way how it works. So here we are seeing economy option. So this is our queue, and let's say we have configured the maximum warehouse is equal to 3, and so hence these all 3 warehouses are available into our Snowflake for us. And then so let's say the query 1 has arrived, so immediately the query 1 will get allocated to warehouse 1, and its warehouse 1 starts execution of the query 1. So the scenario here is, let's say the query 1 is arrived at 11 a.m. and let's say the query 1 take the 10 minutes for the execution, started execution by 11 a.m. and the next 10 minutes the warehouse 1 will be busy for the execution of query 1, and meantime the query 2 has arrived into queue, and so the query 2, let's say query 2 is arrived by 11 to a.m. So after 2 minutes of a query 1, the query 2 has arrived. So query 2 must be allocated to any of the warehouse. Warehouse 1 has finished the execution of 2 minutes, so it will be busy for next 8 minutes. Now economic scaling policy option, it will check the warehouse 1 busy for next 6 minutes, at least for 6 minutes. So it will redirect the query 2 to warehouse 2, because the warehouse 2 is in idle state now. So query 2 is get allocated to warehouse 2, and the state of the warehouse 2 is become running. So let's say query 2 has arrived by 11:02 a.m. and it will take again the 10 minutes of the execution. After query 2, query 3 arrives into queue and it is arrived by 11:06 a.m. So whenever the system detected that the query 3 is arrived into queue and it should be get allocated to any of the warehouse, the Snowflake will check the timing of the query 3. It is arrived at by 11:06 a.m. So the Snowflake will check the timing of warehouse 1 and warehouse 2, both which are currently running. So the warehouse 1 is about to finish its execution because the query 1 has started execution by 11 a.m. and now the query 3 is arrived by 11:06. So the only 4 minutes is left to finish the query 1 into the warehouse 1. Unlike to the standard option, instead of allocating the query 3 to the warehouse 3, it will wait for 4 minutes to finish the query 1 from the warehouse 1, and then once the query 1 finish its execution by let's say 11:10 a.m., the query 3 will get assigned to warehouse 1 for the execution. So instead of allocating the query 3 to the warehouse 3 and starts the warehouse 3, it will wait for 4 minutes and then it will allocate to the warehouse 1 for the execution. The key point is in the economy option, the Snowflake will check the status of each warehouses which are currently running, and it will calculate the timing which will make sure that the warehouses will be busy next 6 minutes. So if the timing is less than 6 minutes, then the next consecutive query will wait to finish the current execution query from the warehouse, and then query which are in queue is get allocated to the free warehouse. So this is how the economy option works. Hence, instead of starting the new warehouse, it will wait for 4 minutes. Hence, the compute resources or the consumption of credit is less in the economy options, but the performance is slow because it will wait for 4 minutes to complete the query 1 from the warehouse 1 of the execution, and it will delay by 4 minutes. So this is how the standard option and the economy option works for the scaling policy. So let's look at how economy option is work for the warehouse to shut down. So similar to the standard scaling policy, economy option is also works same to close or the shut down the warehouses. In economy option, after every 5 to 6 consecutive successful check which is performed at every 1 minute of interval, which determines whether the load on the least loaded warehouses could be redistributed to other warehouses without spinning up the warehouses again. As I have shown in the last example of the standard scaling policy, how the warehouses get shut down. So in the standard option, after every 2 or 3 consecutive successful checks, which is performed at the 1 minutes of interval, the same similar way, the economy option perform the operation to shut down the warehouses.